Hey guys, welcome back to this video series where I show you how to build SaaS applications using Cloudflare Workers and the Workers platform. So if you've been following along, so far we have gotten the application set up, we have the project set up, and we've also set up the workflow that allows for the creation of the different steps. In fact, let's go to my screen so I can show you what we've completed so far. So we've done the flow of receiving the request from the user. So the user can send a request that gets to a worker that spins off a workflow. And we've also created the templates for the various steps of the workflow. So the step for checking for the key in the KV store, the step for spinning up a durable object to get that request rendered, and lastly we have a template for the step to get that article emailed to the user. So that's all well and good, but in today's video we're going to be focusing on the meat or the brains of this SaaS software, which is the durable object that actually gets the article rendered. So that's this bit of the architecture diagram. So we'll need a durable object that maintains a live connection to the browser rendering API such that it's able to spin up new tabs and get articles rendered. And then after the article is rendered, to get the article cached in the KV store, and then it returns. So it does the whole rendering bit, and that's what we're going to be focusing on in this video. So I hope you're ready to get into it. I am. This is really exciting, and of course if you need to take a look at the code, it's all right here in this GitHub repository, megaconfident/web to Kindle. So if you want to take a peek and look ahead, everything you need is going to be right there. And with that, let's get started. Awesome. So before going into writing the code, I'd like to explain why it is we need a durable object in the first place. Why is it we need a durable object? Why can't we just directly call the browser rendering API to get all of the articles rendered and then cached later in the KV store? So I put together this quick diagram to explain what happens when a request comes in to get an article rendered. So you have a request coming in, and that request connects to a cloud browser instance, which is just like you have a Chrome browser in your computer, but in this case it's living on Cloudflare Workers. So it connects to a cloud browser instance and then opens a new tab to get that article rendered. And that happens for every request that comes in. Well, this is fine if you only have a single request coming in maybe once an hour or once in a while, in fact. But the moment you start having multiple requests coming in, that becomes a challenge. So for instance, if you have 3 requests coming in, say we have 3 users trying to use the app at the same time, and we have 3 requests coming in, this is what will happen. So we have each of these 3 users launching a new browser instance to handle each of their independent requests, and the browser instance then opens a single new tab page to get the article rendered and returned back. This is very wasteful because it means if you have 100 users making a request in a single second, we'll have 100 browser instance, and that's going to quickly hit the limits the browser rendering API has, and it's just not an efficient way to utilize resources. So a better solution will be to use durable objects. And don't forget, that is why durable objects was designed in the first place, because it's able to maintain state in the cloud. That's building serverless apps. It's able to maintain that state. In this case, we're setting the state to be a connection to a remote browser instance. So you have a durable object that maintains a connection to a remote browser instance, and because it has that connection maintained, that connection saved live, for every request that comes in from a user, it's going to be able to connect to the same browser instance, and instead of launching multiple browser instances, it's going to instruct that browser instance to instead create a new tab. So if you have 3 requests coming in, as you can see in this diagram, all of those requests will hit the same durable object, and because the durable object has a single connection to a remote browser instance, it's going to tell that browser instance to open up 3 new tabs to render the articles and close them when it's done, which is a way more efficient use of our resources. And of course, this scales. If we have 1 million requests coming in, a second. The durable object is going to be able to handle that, because instead of launching a million browser instances, it's just going to be opening up a million new tabs, and that's way more efficient, and it's going to help to utilize resources more effectively. So this is what we'll be coding in this part of the playlist, and with that we can get started. So I'm going to go open up my terminal, and this is where I have my editor opened up. Let's go open up the browser.ts file, and don't forget, this is where we have the template for the durable objects we started coding the last time. Now we're going to start implementing the logic to get the article rendered and cached. And to get started, I'm just going to start by defining a variable that is going to specify how long we want this durable object to live. And that is because by default, a durable object only lives for as long as the request takes, which in most cases is just going to be 30 seconds of the CPU processing time, and when it's done, it shuts down after 10 seconds. But we want to design this durable object in such a way that it can live for as long as we want to. In this case, I'm going to make it such that it lives for as long as 10 minutes, which means any request that comes in between that 10 minutes time frame is going to be handled by this durable object, which is going to also be maintaining a live connection to a remote browser rendering instance. So this is going to be const live time, which is going to be 10 minutes. So that's 60 times 10. All right, that looks good. So we can head back here. And let's start writing the logic we need. Before actually doing that, I'm going to need to create a variable here to keep track of how long the durable object has been alive for, so that we know how long is left within a 10-minute timer, and we can like deduct that from how long it's been alive. So I hope that makes sense, and it's going to make more sense as you see the code come together. So let's create a state for timer. And this is going to be number. All right, and here we can create that state. We're going to set this to 0. All right, so we have the timer state now, and we can start writing the code to make all of this come together. The first thing I'm going to do here is I'm going to set the timer to 0, because at this time the application isn't running and the durable object hasn't started doing anything. So we can reset the timer state to 0. So we can set this to 0 again, and then we can go on to start the process of connecting to a browser. So what I'm going to do is I'm going to do a check to see if we have a connection to a browser. If we have a live connection to a browser, we can skip trying to reconnect or creating a new connection. But if we don't have a connection, then we need to go in to create a new connection. So this is going to be the browser, and we're going to check here to see that we have a live connection. This dot browser dot is connected. All right, if we don't have a connection, here's where we try to go create a new connection. So let's do a try catch. If we have an error, we're going to console.log the error. But if we don't have an error, or if nothing goes wrong, this is what we actually want to do. Or actually, this is the logic for connecting to the browser. So this is this dot browser. We're going to cache that in the browser state, and here is where we connect using Puppeteer. So this is going to be an await puppeteer.launch. Want to launch a browser, and this is going to be the browser coming from the environment that we set up earlier. So this is going to be browser, and we can also tell it how long we want this browser to live. So this is keep alive. By default, I think this defaults to 10 seconds. But we can extend that to as long as we want to, and we can set this to 10 minutes. I think the max limit is 10 minutes. So this is going to be 60 times 10, and it's in milliseconds, so we have to convert this back to seconds by multiplying that by 1,000. And with that, that looks good to go. So we're able to check to see if we have a browser connection, and if not, we create a new browser connection that is cached. So using this browser connection, we can actually start rendering the article. And to do that, we want to create a new tab page, visit the article, get it rendered, get it cached, and that's what we're going to do right now. So I'm going to create a page, which is going to be await this.browser.new page. And what we want to do with this page is we want to go visit the URL that was passed into this render and cache method of the durable object. So this is going to be await page.go to. So we want to go to that URL and we want to wait until we have network idle 2. So this means that we're going to wait until there's fewer than 2 connections in a 500 millisecond limit in the page, which means it's done downloading all of the HTML, CSS, and JavaScript file, and it's mostly done rendering. So we're going to wait until all of the files are downloaded and the page is ready. And then what I'm going to do is we're going to use the ClickCMP library we installed while starting up this application to dismiss any banner, cookie banner that may come up on the page so that we don't have that in the rendered article. So this is going to be a wait, ClickCMP, and we pass in the page. All right, that looks good. So now we have that page rendered. We can then take this page that has been rendered in the browser and convert it to a PDF file. So this is const PDF equals to wait page.pdf, and we can tell it what settings to use for rendering this PDF. I'm just going to set the print background to true. So print background to true. And that's all, because I think the format by default is going to be in letter. So I think that should be good to go for us. And after that, we can close this page. We're not closing the browser. Remember, we're not closing the browser connection. We're just closing this particular page. So this is going to be wait page.close. And with that, we are good to go when it comes to getting the page rendered. So let's go to the next step, which is getting this rendered PDF cached in the KV store, and that's quite easy. So I'm going to use wait env or this.env dot article cache, and I want to put stuff in the cache. So for the key is going to be the page's URL, and for the value is going to be the PDF file, which is in bytes. And we can set an expiration TTL, which is how long we want this article cached. I want it to be cached for 7 days, after which it's going to be automatically deleted. So this is going to be 60 seconds times 60 makes an hour times 24 makes a day times 7 makes a week. So it's going to be cached for 1 week, after which it's going to be deleted. And at this point, we can reset the timer to 0, saying that, okay, we've done all of this stuff, but we're not going to count this as a part of the 10 seconds we want our durable objects to live for. So what we want to do now is, since this article has been rendered, we want to set an alarm for the future so that this durable object is reawoken, like it's woken up again. So let's get that done. We can say if await this.storage.get alarm. So if we don't have any alarm, we want to create one. So we can use await this.storage.set alarm, and we want to set the alarm for 10 seconds in the future. Remember, the durable object is going to be automatically cleaned up after 10 seconds. We want to set an alarm for 10 seconds into the future so that instead of this durable object being cleaned up, it is kept alive, or it remains alive. So this is date.now plus 10 times 100 or 1000. So that's 10 seconds converted to milliseconds. All right, so that's what we want to do. Now, when this alarm fires, when this alarm here fires, it's actually going to run the alarm method. And in the alarm method, we can specify what we want to happen when the alarm fires. So for this durable object, if the alarm fires, we want to do a couple of things. We want to increment the timer and keep track, saying that, hey, we know this durable object has been alive for 10 more seconds. And then we can do a comparison to see how long the durable object has lived in comparison with the alive timer, which is the global timer we created here. So we'll do a tracking to see how long it has lived compared to the alive timer. And if it has lived long enough, that is for the 10 seconds we want it to live for, we can let the durable object die and then we close the browser connection. But if not, what we're going to do is set another timer so that in 10 seconds into the future, it's woken up again and it's able to respond to requests that comes within the 10-minute limit. So let's get that done. So when the alarm method fires, what we're going to do is increment the timer. This.timer equal to plus equal to 10. And what we're going to do is do a check. So if this.timer is less than alive time, what we're going to do here is just set another alarm for the future. So we have that code here, 6. And we can just paste that in. We set another alarm for the future. Else, if the durable object has lived up to 10 minutes, we want to let it clean up automatically. So we're not going to be setting any more alarms. But what I'm just going to do here is clean up the browser. So if we have a browser connection, we're going to await this.browser.close. So at this point, we just clean up the browser so that we don't have any dangling browser connections. And the browser itself, that's the connection to the remote browser, closes. So I think all of this is good to go. Now what I'm going to do here is quit my terminal because this has been running for a while now. And we can do an npm run deploy. All right, so let's give this a spin. I'm going to open up my API testing tool. So we have the URL set to example.com and for my email address set to my work email. I'm just going to hit the send button to see if this works. And we have the message saying that, hey, the workflow has received this request and it's being queued to be processed. And if I head back to the terminal, let's see if we have any errors. It doesn't seem like we have any errors. So I'm going to go back to my Cloudflare dashboard and I can scroll down here to workers and pages. And we can go take a look at the workflow. So we have the workflow for the starter. And this is the second workflow that we ran. This took 5 seconds to complete. It doesn't look like we have any errors. So we can see that all of the steps ran successfully. We don't have any errors. But to see if this actually works, what we can do is go to storage and databases and take a look at our KV store. So we should have a Web to Kindle articles cache for the production KV cache, but we're going to be checking the Web to Kindle articles cache preview, which is what is going to be used during development. And let's see if we have anything in our database right now. It seems we don't have anything in our database. I'm going to check to see why that is. All right, so it turns out I was looking at the wrong KV store. So what you want to look at is the Web to Kindle starter article cache. That's the one you should be looking at. So if you take a look at this and you go to kvps, you see that we have a key of example.com, which is the URL we tried to render. And then the value cannot be previewed because it's a series of bytes and it represents the PDF file of the article we just tried to render. If you go try to download this and you rename the file extension, you notice that it's the PDF file of the example.com website, which means the process works and we're able to get that article rendered and cached into the KV store, as you can see. So the workflow process works great, and this is good to see. So we have the step 2 done now. We're able to create a durable object that connects to a browser rendering instance, opens up a new tab, gets the article rendered, and then gets it cached in the KV store and returns. So this part of the product is done, and in the next video what we'll do is I'll show you how to set up sending an email to the user's Kindle device and then checking to see if the article has been cached before, because we already have KV set up and all of that is being cached right now. So we'll go back to step 1 and we'll write the logic for checking to see if the article has already been cached, so we can pull it out from the cache and we don't have to go through step 2, which involves like rendering a new article. All right, that's been it for this video. I'm going to see you in the next one. Take care. Bye.